This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
I'm going to write it here. I'm going to call it sum reverse. So I'm taking a constant matrix, a constant vector of integers as a parameter, and I take it as a reference. That's why it's constant. And I iterate through all the rows from 0 up until the size. I increment it. Since I'm finding the sum r is initially 0, and here I just add it up. So sum r plus equal to what? Now this is the most important part here. Matrix of I of mat size, which is n, mat size is n, minus I minus 1. This is the j coordinate basically. And in the end I'm printing it. Cout sum of the reverse diagonal is sum r. Now again, the main and the reverse diagonal makes sense only when we are dealing with square matrices, meaning number of rows and columns are the same. That's why if the number of rows and columns are the same, I also call the sum reverse function and pass it with the mat parameter. Pass the matrix that I've already defined here and fill it with data. So let me run the code, and I'm giving 5. So this is the sum of the diagonal, and sum of the reverse diagonal is 35. If you don't trust me, just add up numbers 5. Usually it's the element which is on the top right place is equal to the element of the bottom left one here. Then 8 with 8 and 9 goes here. It's usually like that in this case, particular case. So this is the reverse, and its sum is 35. Okay. Now this is for the matrices. Now let's go for the preparations for the finals. You're going to see some stuff that we have already seen. But anyway, let's do it again. The first question is this one. The output, which is similar to the trace. So download today's code, today's samples. We are going to write the codes here. And I don't know why, but I enjoy writing them on board rather than writing them in the compiler. I don't know why. Anyway, we are going to cover like 7 or 8 examples, and you can see the others at your home. And the interesting part here, and this is the last thing that we are going to learn for the CS201, is this guy here, static integer. Do you know what's a static variable or not? If it doesn't change, it's called a constant. But if it's a static, this is what happens. When you call the function, this function here, the function, it's called like that, for the first time, it is going to be initialized to 0. And when the function is finished, when it finishes, everything related to that function is going to be deleted, except for the static variables. So when we call it for the second time, it remains there. We don't initialize it to 0. For instance, it's initially 0, then we increment it and it's 1. It stays 1. When we call it again, it's 1. But we increment it again, so it becomes 2, and it stays 2. When you call it for the third time, this line is not going to be initialized again. It's not going to be executed. It's executed only once, when we call it for the first time. And we call them for the consequent times, again and again and again and again, the variable is there with the last value it had, okay? So we are going to see it right here. We should print the output of this program, so let's start. Let's see what we are doing. This is called, okay, not tracing, but something similar. So, this is main. Should I write with the black one or this one? Black one is better, because it's about to finish, that's why. Okay, so this is main. And in main I have an integer b. Initially its value is 0. I have another integer I. Now this is what I'm doing. I execute this for loop with I being 1. So I is 1 initially. Is I smaller or equal to 3? Yes. Then I go inside and I say b is equal to b plus the function. This is not uppercase b. It is like this. Okay, so b is equal to the old b, which is 0, plus the value that this function is returning. We are calling the function with the parameter I, basically with 1. So and the function I is here. So we are calling the function. It takes a as a parameter. This a here is I, and I is 1. So we send 1 as a parameter, and we have a here, and a's value is 1. Now we define a static integer b, and this is very important, static integer b. I'm going to write it as static b. Initially its value is 0, and this line is executed only once. So this is static. Then I say that a is equal to, then I increment b here, b plus plus, from 0, now it's 1. I change its value to 1. And I say a is equal to a plus b. 1 plus 1 is equal to 2, and a is 2 now. And I return a. So I'm returning a, which is 2. The function I will be 2. So I have here this 2, plus the value of b, and the value of b is 0. So 0 plus 2, it's going to be 2. 0 plus 2 is assigned to b, and b is 2. This function, when I return the value, the function finishes, and everything associated with that function is going to be erased from memory. So this a is going to be erased, the function, except for the static b. This is going to stay there. Okay? Now let's see what happens. I increment I by 1 here. So I becomes 2. Is 2 smaller or equal to 3? Yes, it is. Then I go here and I say b is equal to b plus the function of I. Again, I call the function. But I here is actually a in the function. And when I call it with I, the value of I is 2. So basically, the value of a is 2. Now let's see what I'm doing. Since this is a static variable, the first line is not going to be executed, because we already have b here. That's why I'm not going to put it to be 0. I'm continuing with the second line. So the first line is executed only at the first call of the function. So b is equal to 0 is not going to be executed. I go to the second line, and the second line says that b is equal to b plus 1. So b is going to be 2. Then a is equal to a plus b. So 2 plus 2 is 4. And I'm returning a. This is I'm going to write return. So I'm returning 4. The function I, the value that it returns will be here. So we have here 4 plus b in the main. B is 2 and 4, it's 6. So b is b plus 4. It was 2 plus 4, it's 6. It's assigned to b. Everything that is associated with the function, again, is erased. So this a is erased. We don't have this 4 anymore, but the static integer stays there. Now we go here and increment I to be 3, I plus plus. So I is now 3. Is 3 smaller or equal to 3? Yes, it is. We go inside. We say b is equal to b plus the function of I. I is 3. So a in the function, it's called I here, it's a there, is going to be 3. A is 3. We don't execute the first line. We have a static integer b. We go to the second line, b plus plus, meaning b is going to become now 3. We say a is equal to a plus b. 3 and 3, it's 6. And that value is assigned to a. And we return a, meaning we return 6. So here we have 6, the return value. 6 plus, what's the value of b? It's 6. 6 and 6 is 12, and that 12 is assigned to b. When I return the value, everything that is associated is going to be erased. Only the static b remains. So I go again here. I increment I. I is 4. Is 4 smaller or equal to 3? No. I print b, and this is it. So what's the output? Output meaning what do we see in the console? What's going to be printed? It's b. And this new line, so it's 12. Okay, when I return 0, the main finishes, the program finishes. What do you think? That static b is going to stay there or not? Yeah, of course it does. So when the program terminates, finally, we can get rid of this static b, okay? We don't have anything here. Everything is erased. So this was the output. Any questions? So static variables is the last topic that we learn in CS201. For the rest 2 hours, we are going to do just a repetition of stuff that we have already seen. We have seen this also. And we're going to see another example. So expect something like this in the exam also. You had it in the first midterm, in the second midterm. Expect it in the finals also. Now let's go with the fourth example. And it's also, we should do here also something similar. We should print the output. Questions? 2? Yeah, it's 2C actually. But we should cover the questions that are important for the finals. You can ask me during the break about that, no problem. Just let's finish with this one. If you have questions related to this one, yeah, sure. Otherwise, you can ask me during the break. Okay, so we should print the output of this program, but there is something interesting here. We have those variables. And how do we call those variables that are not inside a function? What? Global variables. So we have global variables. They are not associated to any functions. Actually, they are associated to all of the functions, not particular to any of them. So all of the functions, main, my function, whatever, can see those. And this is a kind of an example that deals with the scope of the variables. But let me clear it. So I'm going to write something like this, global. And I have a variable called x. Pay attention to this one because it's interesting. X is initially 9. And I have a variable called y. And y is initially 5. Okay, so this is global. Now I'm going to main. This is main. And global can be seen from all of the functions, including the main function. In main, I always start from main. This is not main. So let me call main. Let me go to main. And we always start with main. In main we have this stuff. I have a, and the value of a is 10. I have x, and the value of x is 5. And here I'm going to have the output. I hope it is going to be sufficient. Meaning, what are you going to see in the console? So this is my output here. I execute this line, cout x, y, a. I'm printing x first, then y, then a. But we have two x's, one x here and one x here. Which x are we going to print? And both of them can be seen from main. What do you think? The global one? I'm afraid you're wrong. You always go with the one that is closer to you. Okay? So you print this one first. This is called the scope of the variable. Okay? And you'll see inside main we can define another x inside the block. If you define another x inside the block in the main function, then this x is the last one that we are going to deal with. Okay? So the closer you are to the variable, you can see it and you are dealing with that. Okay? So when I print x, y, and a, I'm meaning about 5. Then I have an empty space. A is 10, empty space, and x, y, y 5, 5. I'm printing x, I'm printing y, which is 5, and then I'm printing a, and a is 10. Okay, so I want to print my function. My function obviously is going to return something, but it's going to execute its code. I'm calling my function, and remember, my function is going to return something, and the return value is going to be printed here. But before printing it, let's see what my function is doing. So I'm calling my function. This is what it's going to return, but we'll see that later on. So we are here. This is the main, and this is my function. Of course, my function can see the global data, but not the data inside the main. So I'm calling my function with empty parameters, no parameters, and I define here y. The value of y is 0 initially. Then I have a. The value of a is 5. And I'm printing. I'm printing x, y, and a. So do I have x here? No. Then I go to the global x, which is 9. So I'm printing 9. X. Then I'm printing here y. But which y? The one closer to my function. So it's 0, 9, 0. And I'm printing a. It's 5. Now I say if y is smaller than x, I go inside this block. And this is also interesting. Y is smaller than a. Is this true? Is 0 smaller than 5? Yes. That's why I go inside this block. And I'm going to write that block, which is part of my function, like this. Kind of, not a sum function, but it's a block. I'm defining, if I wrote only this stuff, y is equal to a multiplied by 2, it's okay. But when I say integer y, I'm directly allocating a memory here, a box, for an integer variable, and that integer variable is going to be called y. And I said this y here is equal to a multiplied by 2. So a, do we have a here? Yes. 5 multiplied by 2, it's 10. So this y is equal to 10. Now I'm printing x, y, and a. What's the value of x? I don't have x here, I don't have x here, I have x here, so I'm printing 9, x, then y. Which y is going to be printed? This one or this one? Of course, this one which is closer. We have two y's, but this is closer to the block, so this y is going to be printed, so 9. Then we have 10, x, y, and a is 5. When I go outside of the block, everything that was associated with this block, the variables, are going to be erased. So this is going to be erased. We don't have it anymore. If you want to deal with y, this is the y we're dealing with. Now what do we have here? Here we have a plus plus, y plus plus, x plus plus. We increment them by 1. So a was 5, now it's going to be 6. Y was 1, now it's going to be 0, now it's going to be 1. And we have x plus plus, this x here. It was 9, now it's going to be 10. And I'm printing this guy, x, y, a again. So x is 10, y is 1, and a 6. And I'm returning a plus y plus x. A 6 plus y 7 plus x, it's 17. So I'm returning 17, and everything associated with the function, my function, is going to be erased. We don't have anything. This is returned. Now you remember that we were here. We stopped here when we called the my function. So my function returns 17. That's why we print the 17 and we go to a new line. I'm going to start over here because I don't have place. So I print 17, the return value, and I go to a new line. Now I ask if x is equal to y. Is x equal to y? Now we are in main. X is 5. We don't have any other y here, so we go to the global y. Is 5 equal to 5? Yes. If it is the case, this is what we do. We open a new block. We have a new block here. I'm going to write it like this. This is inside the main. And here, since I have this integer clause, integer sentence, integer word, I'm defining a new variable called a, and its validity, that its scope is inside this block. I have a box for a, and a is equal to x plus 2y. A is equal to x, which is 5, plus 2y. 2y is 5 multiplied by 2 is 10, plus 5 it's 15. So this a is 15. Yeah, but we have another way here. Just that we had it in my function. And this a are not the same. Okay, this is valid only for this block. The scope, the validity. Yeah, we can have it the same. Yeah, we can define it multiple times. And always when you redefine it, you're dealing with the newest defined, with the latest defined value, closer to you, okay? So 2 multiplied by y is 10, plus x is 5, so the value of a is 15. I increment y by 1, y plus plus. That y is this y here, so y is now 6. And I print out, I print x, y, and a. X is 5, y is 6, a is this a, okay, 15, not this one. A is 15. Now I go outside from the block, and everything associated with this block, I don't have it anymore. It's going to be basically deleted.
Will y be 6 now always, or it will be only set at the top?
I didn't understand you.
Like y was 5 before, right?
Yeah, y was 5 before.
Now it will be 6 for all the remaining?
Always it will be 6, because we have only one y. Okay, this is the global. When we access y, we access this global one. Okay, so this is finished, but the changes remain. Okay, so this is going to be deleted. We go here, increment a, x, and y by 1, all of them. This a here is going to be 11. Then x is going to be 6. Then y, this y here is going to be 7. And I suppose I print them, yes, x, y, a. X, y, a. So it's 6, x, y is 7, a is 11. And this is it. I'm finished. So this was a kind of a topic that we covered, I think, in the third week, I think, which was called the scope of the variables. Okay? And expect something similar in your exam. Any questions? I think you don't like those kind of questions, or not? They are tricky for you, or no? But they are doable, I mean. And they are very important, if you ask me. Those kind of questions are important since you understand, I mean, if you can do them, you really understand the programming. All the principles behind the programming. If you can come out with the output yourself, that means that you understood everything about that particular program. And that's important. If there are no questions, and I think we have time, we can go with another example. Namely with the 8th one. Yes, this is it. Okay, read it and try to understand it and try to do it yourself. The 8th example. So, what should you do here? We have a vector of dates as a parameter, and that vector, in that vector we should count the number of distinct dates. I mean, if a date is repeated twice or thrice or 4 times, 5 times, we should count it only once. Is there any hero that can do this program, can write this program, or not? It's not hard. While I'm erasing the board, you can just think about the way you can solve this particular question. Think for the solution. I'm going to tell you the algorithm first, and then I'm going to write the code for this particular example. So we have a vector of dates. You remember the class date. I'm not going to write it again. And let's say I'm going to write the dates normally, but when I say a date, we have something like this, and in that we have a variable for the day, the month, the year, and they have appropriate functions like plus and month, day, and so on. But I'm not going to do it. I've done it like 3 times here. That's why I'm going to write the date like this. So if you're not aware what I'm talking about, you can go check previous videos or previous recitations. You'll see about the class date and all of the member functions of the class date. But this is what I'm trying to do. So this is a vector which is called D. and I have here dates. Let's say I have here 29th of December 2016. Then I have another date, which is 1st of January 2017. Then I have another date, which is 29th of December 2016. My job is to count the number of distinct, unique dates, meaning if they repeat twice or 3 times, I count them only one. Okay? So how am I going to do that? For instance, this date here with index 0 and index 2, they are the same. That's why I'm going to count them only once. If I have other 29th of Decembers, I'm going to count them only once. Of course, if it appears only once, I'm counting it only once. So what I'm going to do is the following. Maybe we can come up with other easier solutions maybe, but this is the way we are going to solve this program. I'm going to define the temporary array, and I'm going to put those dates here. So I start from index 0, and I see I don't have anything. Do I have 29th of December 2016 here somewhere? No, I don't have it. That's why I'm writing it here. 29th of December 2016. I go with this one. Do I have it here? No. And of course I have a counter here. Initially the counter is 0. When I put this guy here, this date here, I increment it to be 1. Then I go to the second index, to the index 1, second data of the vector with index 1. And I check, do I have it here? If I don't have it here, I increment the counter, so it's now 2, and I write it here. 01, 01, 2017. Then I go to the third index, the third element of the array, of the vector, and I check it. Do I have it here? Yes, I have it. I'm not going to write it again, and I'm not going to increment the counter. And I repeat this up until the end. So this will be our way of dealing with this particular case. For this reason, should I erase it or not? I think it will be sufficient. Let me give it a try. So I'm writing the program. First, I'm going to write the program for this part here. Namely, I'm taking this array and a certain date, and I want to check whether this date appears here. Okay? So the function basically, the function will return true if the date that I'm sending appears in the array. And it's called, the name of the function is called exist. What I'm taking is a constant vector of dates. Of course, I take it as a parameter, that's why I put the constant sign here, since I don't want to change it. And I'm taking another date, which is called item or whatever, and I want to check whether this item is in this vector here. If it exists, I return true. Otherwise, I return false. So, I'll start with this for loop. Integer I is equal to 0. I start from the 0th element. I is equal to d point size. I go up until the end of the vector. I plus plus. Now what should I do? I should check whether this date, for instance, this might be 29th of December 2016, whether this date appears in the vector. And how do I check that? Very easily. I do something like this. If, how do I access the 0th or the 1st or the 2nd element of the array? If d of I is equal to the item, then what should I return? True, it exists. Return true. If I don't return true up until the end, that means that this date does not appear in the vector. So in the end, I return false. remember, we are expecting a Boolean value to be returned, either true or false. If I return it once, I don't have to check it. Okay, so if I have like 1 million dates here, and if the first date is a match with this item, I return true and I'm not going to check others. If I return something, the function finishes. I might have 1 million lines of code here that are not going to be executed. So this is one part of the problem exists. And another part is kind of straightforward. So this is our, not main function, but this is the main function for the problem we are dealing with. Here I count the distinct dates, and I return its value. So, distinct. I take also a constant vector of dates, of type date, which is called D, and it's a reference. That's why it's constant. Now I declare this temporary vector here, vector of type date, which is called temp. Initially it's 0. I define variables, count. This is the counter I told you about. And now let's go put one by one those elements here if it does not exist. So I'm going to use this function here. For integer I is equal to 0, I is smaller than d point size, I plus plus, if a certain date does not exist, then I'm going to put it and increment the count. Does not exist, I mean if it returns false, in order to be true, I'm using the not operator. And I'm calling exist. If a certain date does not exist, then put it there. So exist of what? Of this temporary vector here, which was initially empty, and the concrete index. So I take this one. Does it exist here? No. Put it there. This one, does it exist? No. Put it there and increment the counter. Take this one. Does it exist here? Well, it exists. Don't do anything. Okay? If it does not exist, d of I, then what I'm doing, I'm putting it to the temporary vector and incrementing the counter. So, if it does not exist, I put this element in the end, and which functions do I use to do that? Pushback. I always put it in the end. So pushback, d of I have the element there, and increment the counter by 1. So count plus plus. And this is it. This is for this guy here. And what should I return in the end? I'm expecting an integer, which is the distinct dates here. Of course, in the end I don't have place here, but in the end you return the counter. Return count. Okay, this is it. Any questions about this program here? Do you want to have a break or not? Yeah? Let's do another example. Since you want to have a break, I'm not going to give it to you. Let's do something similar. Let's go to the 10th example. And I'll give you a break then. So read it, try to understand it, and let's do it together. Any questions, by the way, about this program here? Is it easy to understand? Push it in the end. Okay, I take it, push it here, appends it in the end. Questions? I mean, I don't have to repeat it again. If you don't understand anything, if there is something you have to ask, this is not for CS201 anymore. This is for the advanced programming stuff. Okay, just raise your hand or your voice and ask me. No questions? Okay. Read the 10th question, try to understand it, and tell me about an algorithm or a way how to deal with it. Okay, so did you understand it or not? How can we do that? Can you give me an idea? We have the 10th question. We should pick and display 10 distinct, unique, unrepeated, random integer values between 1 and 100. And distinct means it cannot appear more than once. And they should be random, meaning we should use the rand generator class. So how are we going to do that? Just give me an algorithm, a way you think it's going to work for this particular case. Yes, a vector then.
So we will decide the size of vector as 10, then we create random numbers.
Yes.
And for each number, after we put a number, we can check
whether it exists or not in the vector. If it exists, we should generate another one. This is very nice. Even your solution is better than the solution we are going to write right now. So your friend is saying the following. We're going to create, since we should come up with 10 distinct integers, he says, okay, let's do something like this. Let's put them to a vector from 1 to 9 with indexes. And I put numbers here, let's say, and I generate vectors from 1, numbers from 1 to 100. Let's say I generated 35. I put 35 here. Then I generated 73, and I put 73 here. Then I generated 35 again, but 35 exists here, so I regenerate another one. Basically, if a number exists here, I should regenerate it again. Should up and check whether it exists. If it exists, I regenerate it again, If it doesn't exist, I put it here. And we have here 10 elements. Okay, so this is the algorithm of your friend. But we are going to do something more complicated, and I think your friend's algorithm is better. What we are going to do is the following in our example. I'm going to have a vector of Boolean values. So this is Boolean, meaning true or false. From 0 up until 100, because we start from 100. The 0th index, I don't care about it. It's going to be false initially. And everything else is going to be false. I have 101 elements. Let's say I generated, so this is 27. Let's say 35 is here. Those are false. Everything is false, meaning I didn't generate any of them. Let's say I generate 35. When I generate 35, it is going to be true. And I check it. Then I generate 27. And 27 is going to be true. I try to generate 35 again, but I see it's already true. So I don't take it into account and regenerate another number, okay? So this is the algorithm we are going to use. Instead of using vector of 10 numbers, we are going to use of 10 integers, we are going to use a vector of 101 booleans and do the same thing, okay? Again, we should write here a program, you see, not a function. When we say a program, we start from main. When we say a function, we write only a function. I'm going to use this notation, include all that is needed. In this case, I need IOStream, I need the random generator class, namespace std, what else? Everything. I don't want to bother with that. So, we start with the program, main, and I define this vector here of 101 elements. So it's bool of Boolean values. It's called numbers 101 because I generate numbers from 1 to 100 and I don't care about 0. I just put it there because I start counting from 0. This is called built-in array, not a dynamic one. We cannot use pushback here. The number is fixed. And usually when we know that we should generate from 1 to 100, we don't generate more than 100. It's fixed. We use built-in arrays. Okay. I define another variable of random generator class called generator. And I define a counter. Initially it's 0. In this counter I count the numbers. How many numbers I've generated. This counter in the end should be 10. So, in order to be sure that these values are all false, I'm going to iterate it with a for loop. Integer I is equal to 0 up until 101. Since we have 101 elements. We cannot use the size property here since it does not exist. This is a built-in array, not a dynamic. Dynamic means that its size increases. Okay? We can use pushback. Here we cannot use pushback. It's always constant. It's like that. Okay? That's why I know that's always 101 and stays like we have 101 elements and it stays like that. So I plus plus. And everything is said to be numbers of I is equal to false. Meaning everything is false. We haven't generated any number up until now. Now, I'm continuing here. While the counter is smaller than 10, because I have to generate numbers, I generate numbers, a unique number. This is the number that I'm generating here. Number is equal to generator, and you remember the random generator class. It had a member function which was called randint. As a parameter it takes the low and the max, and it returns an integer between low and max, in our case 1 and 100. Now I'm checking. I've generated a number, and I want to check whether this number that I've generated appears here. So if I generate 35, I want to check whether 35 is false or not. That's why I check. If the number was not previously generated, and I write it like this, if numbers of, what is the index here? No. Generator is not an integer. Num. Okay. So if num is 35, at index 35, I check whether it's false or not. Meaning whether it was generated previously. If it was not generated, so if numbers of num is false, Not false makes it true, meaning that if it was not generated, then what I'm going to do, I'm going to increment the counter by 1. I have one more element, distinct element. Of course, it's going to be true here, so I cannot generate it again. So numbers of num, index num, is equal to true. And I print the number. Cout number, new line, end line. This is it. Should I add something else here? No, I'm finished. And this is going to be generated for 10 times. I mean, I increment the counter if the randomly generated number does not exist. It's a distinct one. I'm incrementing the counter, and I increment it 10 times. I start from 0. Return 0. And this is it. This is for the main. I say again, the algorithm that your friend gave is kind of maybe more efficient one, because we have a vector